Hello students, today we are going to discuss operational amplifier op-amp. Previous class already we have discussed operational amplifier. Again I am repeating this operational amplifier class. So the content of the operational amplifier basically we will discuss what is introduction, ideal operational amplifier, basic operational amplifier circuits, the other useful circuits like using operational amplifier, what are the functions of operational amplifier, what are the applications of the operational amplifier, and the real operational amplifiers, selecting component values, effect of feedback on op-amp circuits. So generally in operational amplifier, so these are the pin configuration. When you are going to buy, going to market to buy an op-amp, so you will find that is your 8 pin configurations. In operational amplifier, so there is how many number of pins? So that is your 6 pins. Here there are 6 pins. So one is DIL package and another one is your SMT package. So DIL package, that is your all the pins are in your parallel rows. Pins are rows are in parallel, but in surface mount technology package, an SMT package, it is nothing but about surface mount technology package. Surface mount technology, what that directly components are directly mounted on in the PCB. So in practically on operational amplifier, so in operational amplifier, so here there is one, already I told you in your previous class, there are 2 terminals. One is your inverting terminal, another is your non-inverting terminal, another is your output terminals. So inverting terminal, here generally we are applying the input voltage Vi and this your output voltage your V0, and in the 8 pin package, so pin number 1, pin number 2, like 3, 4, and here 5, 6, 7 and 8. The configuration, the serial number is like this. When you are going to market and buy any IC, so there is a symbol is like this, and this symbol indicates the pin number 1. You will count like this, and the pin number 1 to pin number 8. So in amplifier, among the most widely used building blocks in electronics, they are integrated circuits, either in DIL or another one is your surface mount technology package. So in operational amplifier, so here a single package will often contain several op-amps. It may be a single op-amps. This is an op-amp, and here there are how many number of op-amps? There are 4 op-amps, and here there are 2 op-amps. If there is a 2 op-amps in a single package or IC package, we can say that is a dual op-amp. And simply in a single op-amp in operational amplifier, you just read out the circuit. If this symbol indicates that, you will count the pin number 1, 2, 3, 4, and again 5, 6, 7, 8. So this is your this terminal. Already I told you in a operational amplifier. First of all, you must know there is one is your minus terminal, another is your plus terminal, and here there is your one what? There is an output terminals. These 3 terminal you must know. Inverting, minus terminal is inverting, plus terminal is non-inverting, and this is your output terminal, that is your V0. First of all, in any electronic circuits, one is your input pin. Input pin already you are supplying the input voltage, like your collector supply voltage, or maybe in case of transistor VCC. But in case of operational amplifier, there are varieties of the applications of operational amplifier. Maybe 555 timer, digital clock. There are so many applications using operational amplifier. You will get different types of electronic circuits, and there are varieties of the applications of the operational amplifiers. Particularly in a single op-amp, in a IC integrated circuit, so this is your pin number 1 and this is your pin number 2, and pin number 2 is your inverting input. Here already I told you minus terminal, and non-inverting input, that is your 3, and here the pin number 6. So we have the 3 pin. You must know what is inverting, what is non-inverting, and what is your output. Similarly in case of dual pin op-amp, dual means what? There are 2 operational amplifier in a single package. So 2 operational amplifier. In a 2 operational amplifier, here if you look like this, here the pin number 6 is your output. Here the pin number here in dual case is the first one, and this is your second one, and this is your 1 is your output in case of this operational amplifier, and in case of this operational amplifier, the pin number 7 is your output. This your output pin is your 1, and here output pin is your 7, second operational amplifier. Similarly here, this is your 2 and this is your 3, and 1 is your inverting pin number 2 is your terminal, this is your inverting input, and this is your what? Non-inverting input. Similarly here, pin number 6 is your inverting and pin number 5 is your non-inverting. So this is the configuration. Suppose if you want to find out the output, suppose you are giving the input and will obtain the output. How you will get the output? In a breadboard or simply designing board, and you put your operational IC in that designing board, and if you connect input and inverting and non-inverting and output terminal, you will find the output with the help of the CRO cathode or oscilloscope. You will get the output, and you will see the whatever the output obtained at the in CRO, you will get the output. You will find the output. Similarly here, it is a quad operational amplifier. In quad operational amplifier, there are 4 operational amplifier in single IC, and in quad operational amplifier here, like this, what? This is your in particular inverting, non-inverting and output here, and this is your pin, this is your 1, this is your 2, and this is your 3, and this is your 4. There are 4 operational amplifier in a single IC package, in a single IC. So you don't need to remember this all, which pin is your input, which pin is your output. You must know. So simply, as far as your function is concerned, as your choice, how you use the operational amplifier, maybe single op amp, maybe quad op amp, dual op amp, or maybe your quad op amp, means 4 operational amplifier. So now, this is one of the vital, this is your basic things of ideal operational amplifier. So already I told you in your previous class, in operational amplifier, so like this, so this is a symbol of operational amplifier. This is your inverting and this is your non-inverting, and this is your inverting input and this is your non-inverting input, and this is your output. So basic thing is, that is your what? So already I told you in the previous class, there are 4 characteristics, there are some characteristics of the operational amplifier. What are the characteristics of the operational amplifier? Based on the characteristics of the operational amplifier, that then in next step we will go how you apply your what, how to get the output, the particularly input. In case of operational amplifier, this is your inverting terminal, inverting, and this is your non-inverting. This is your non-inverting, and this is your output. So one concept is your virtual ground concept. I told you in your previous class. What is the virtual ground concept? In virtual ground concept, so that is your what? This non-inverting terminal is always grounded, and here if this is your VD, difference voltage, means what? And this is your output voltage V0. So first characteristic of the operational amplifier, the voltage gain AB is infinite. Voltage gain means what? The output voltage by input voltage. So that if the output voltage V0, input voltage is VD, so V0 by VD is your infinity. V0 by VD is your infinity. So VD is the difference voltage, this voltage minus this voltage is infinity. So if the gain is infinity, means what? The difference voltage must be the 0. This is what we can say that the virtual ground concept. Suppose this is your 2 volt and this voltage must be 2 volt, because 2 minus 2 will be 0. If this is 0, then you will get the gain will be infinity. So that's why if this is grounded, non-inverting terminal is grounded, always non-inverting terminal is grounded. If the non-inverting terminal is grounded, means what? So that is you are neglecting the voltage, that is means 0 volt, and this voltage must be 0 volt. So that what? This voltage minus this voltage equal to 0. If this is 0 means this is 0. If this is 1 means this is 1. So that's why to keep the input voltage 0 and to get the voltage gain infinity, so that's why difference voltage must be 0. And this is nothing but our virtual ground concept. So every electronic circuit, negative terminal is grounded here, but in case of operational amplifier, the here positive terminal is grounded. The positive terminal grounded means what? It is 0 volt. If this is 0 volt and this voltage must be 0, that's why something by 0 is your infinity, the gain is infinity. So in case of operational amplifier, this is your equivalent circuit of our operational amplifier. Equivalent circuit what? This is your what? V plus. V plus means what? This voltage, we can say that is your V plus. This potential is your V plus and this potential is your V minus. So here this is V plus and this V minus, and this difference voltage is your VI here. But here I can say this voltage is also VI. This is also VI. So that's why, so in case of operational amplifier, it is nothing but a 2-port network. In electronic circuit, transistor is a 2-port network. In operational amplifier also, we can develop the two-port network. What is two-port network? In two-port network, in case of two-port network, that is your input and this is your output. Input port and this is your output port. Here input port and output port. Output voltage V0. We know that this is your input voltage Vi and this is your output voltage V0. So V0 by Vi is your gain, is your AV, and V0 equal to AV into Vi. So here V0, in case of V0, you can put that is your AV into Vi. AV into Vi. Vi is nothing but what? V plus minus V minus. This difference voltage. If this voltage is your V plus and this voltage is your V minus, then the difference voltage is what? Vi equal to, here Vi equal to V plus minus V minus. So that's why, so this is your what? The voltage dependent source. So V0, this voltage V0 equal to, I can say AV into Vi. This is your equivalent circuit of operational amplifier. Means what? What is equivalent circuit of op-amp? So if this is an operational amplifier, in place of this circuit, that is your here, we can say this is your plus and this is your minus, this is your V plus or this is your V minus, and this difference voltage is your Vi and this is your V0. In place of input, that is your V plus and V minus, and in case of output, we can replace this. The output voltage can be represented by the V0 equal to AV into Vi. So that's what, in case of, in here, this is nothing all about your what? Ideal voltage amplifier. Ideal voltage amplifier means what? The output port can be represented by output voltage. That's why you can say that this is your voltage amplifier. If the output can be represented by current source, we can say that in an current amplifier. So this is your voltage dependent voltage source. Voltage dependent voltage source means what? This is your plus terminal and this is your minus terminal. The output voltage can be represented by what? Input voltage. If you know the input voltage, the output voltage can be represented. So that's what V0 equal AV into Vi, and this output port can be represented by output voltage. That's why you can say that this is your voltage dependent voltage source. Output voltage can be dependent on the input voltage. Once you know the input voltage, then output voltage can be represented here. So in place of operational amplifier, this I can put this circuit. Already I told you in your previous class. So any electronic circuit, input port and output port, if it is a two-port network, so input port can be represented by input voltage and input resistance. Output port can be represented by output voltage and output resistance. So there might be a question, why there is no resistor here, simply a voltage source. So there obviously, if this is not case of ideal operational amplifier, there is also what? There is a resistance is also there. If this is output voltage, obviously this is nothing but output impedance or output resistance are 0. So this resistance is neglected. That's why only we have considered output voltage, because this resistance is neglected in case of ideal voltage amplifier. In case of operational amplifier, ideal voltage amplifier, in case of operational amplifier, here the output resistance is neglected. Why output resistance is neglected? In case of properties of the operational amplifier, the gain is infinite. Gain is very, very high. Some 10 to the power 10, 10 to the power 20, 10 to the power like this. So gain is very high. In ideal case, we are considering infinite, but practically it is not infinite. Some voltage gain, some 10 to the power 10, 10 to the power 20 like this. Output is very high. The gain is very high. So in case of ideal case, the gain is infinite. But in case of practical case, we will not omit this output impedance Z0 R0, because in output impedance is nearly equal to 0 in case of ideal operational amplifier. In case of ideal operational amplifier, the output impedance or output resistance is 0. That's why in this diagram, the Z0 or R0 is absent. So only the two things you should keep in your mind in case of ideal operational amplifier. One is your voltage source, input open circuited voltage source, because what? Input impedance is infinite. In case of input impedance infinite, so that's why in any electronic circuit, that is what? One is your input voltage and series with input resistance. This is your input port, and output there is a source, and this is your resistance. So this is your input and this is your output. In case of either it may be transistor, or in case of operational amplifier, this is your input port the input voltage obviously that is your Vi, and input resistance is Ri, this is your output voltage V0 or output resistance R0. Normally in case of two-port network, there is an voltage and resistance, input port and output port. In case of operational amplifier, and the beauty of the operational amplifier is what? The gain is infinite, input impedance is infinite, and output impedance is 0. If output impedance is 0, that's why you have neglected this resistance. That's why the output resistance is absent in case of operational amplifier as far as output port is concerned. In case of input port, here since the input impedance is infinite, input resistance or input impedance is infinite, is very high. If the input impedance is very high, that's what it is open circuited. The input port is here open circuited. That's why how input impedance is infinite. Why input impedance is infinite? First, you know the basics of what is input impedance. Suppose in case of input impedance is nothing but input voltage by input current. Tell me, if this is infinite, means this is high. If this is infinite, and that value must be what? That value must be 0. If input current 0, if current 0 means what? Open circuited. Voltage 0 means what? Short circuited. Since input impedance infinite, as characteristics of the operational amplifier, as beauty of the operational amplifier, if the input impedance is infinite, input current is 0. If input current is 0, current 0 means what? This is open circuited. This is open circuited here. This is open circuited. In case of operational amplifier, the input port is open circuited here. Due to input impedance is infinite. Output impedance is 0. The output impedance is 0 means what? The output impedance 0 means what? Z0 equal to output impedance 0 means what? There is no resistance in the output circuit, only voltage source. Are you getting or not? So that's why as far as equivalent circuit of the operational amplifier means what? In place of this, you will put this circuit. Means there is an input port and there is an output port. Input port can be represented what? Input circuit is open circuited due to input impedance is infinite, is very high, and output impedance is what? 0. Due to output impedance 0, the Z0 or R0 is absent here, and you must represent there is a voltage source. This is a voltage dependent voltage source. V0 equal to AV into VI. V0 equal, so gain AV equal to V0 by VI. If V0 equal to AV into VI. In place of V0 equal to AV into VI. This is all about your what? Equivalent circuit of operational amplifier. Next what? So here, so inverting and non-inverting amplifier. What is inverting and what is non-inverting? So already I told you in what is inverting. Inverting means what? So that is minus and this is plus. So that is your plus is grounded. We are applying the input. We are applying the input at the inverting terminal. Suppose this is your VI, this is your inverting terminal, and this is your output terminal, this is your V0. So this is your gain, that's your AV. If it is an inverting amplifier, we are giving input to the what? Inverting terminal. So non-inverting terminal is grounded. Why non-inverting terminal is grounded? Because the virtual ground concept, if the gain is infinite, means what? The difference voltage must be 0. The difference voltage must be 0 because of due to virtual ground concept. If this is the grounded and this is VI and what? So V0 and we are giving input to the inverting terminal here. Suppose here VI and here V0 gain AV equal to 2. AV equal to means what? V0 by VI equal to 2. If VI here we can say that in case of non-inverting terminal, there is what? In inverting terminal, suppose V0, suppose this is your 2 volt, the output voltage V0 by VI equal to what? V0 VI equal to what? If AV equal to 2, if AV equal to 2, AV equal to 2 means what? V0 by VI equal to 2. So V0 equal to what? Not 2 into VI. In case of inverting, the output you will get some negative signs. In case of non-inverting, output get the positive signs. Look at this here. This is your VI. This is your simple sinusoidal waveform, and this is your output. In case of a non-inverting terminal, since it is an amplifier, that is raise the strength of the amplitude. Here, whatever the amplitude is increases here because of amplification. So V0 and VI and V0, the phase difference will be same in case of non-inverting. In case of inverting, here inverting, that is your what? That is your 180 degree phase difference. Whatever, if the input is like this, the output minus of this, that is your 180 degree phase difference between input and output Vi and V0. This is non-inverting, and this is non-inverting, and this is your inverting. This is your inverting. In case of inverting operational amplifier, and output you will get what? Some negative sign, that is your V0 by Vi, here AV equal to -2. If the gain is -2 means what? That is an inverting. A gain is equal to +2 is what? That is your non-inverting. Inverting means what? That is a same phase difference. Phase difference is 0. In case of non-inverting, phase difference will be 180 degree. Then what? There are some key points about the operational amplifier. When looking at feedback, we derive the circuit and amplifier from first principles. Normally, some first principles. First principles what? In operational amplifier, always kept in your mind, in the virtual ground concept, the gain is infinite. If the gain is infinite, the difference voltage must be 0. So normally we use standard Cook-Book circuit. What is Cook-Book circuit? Cook-Book circuit means what? There is a designing circuit. When you are going to design in electronic circuits, there are some, what are the standardized value of the every components. From these Cook-Book circuits, what are the specifications of transistors, diodes, what are the parameters we are going to design an electronic circuit. Normally we can say that there is an Cook-Book circuits. So in analyzing this, we normally assume the use of ideal op-amps. So in case of analyzing, so in practical case, our ideal case is totally different. In practical case, in ideal case, we are in ideal operational amplifier, we say the input impedance is infinite and the gain is infinite. But in case of in ideal case, in ideal operational amplifier, we can say that the gain is infinite and input impedance is infinite. Zi is infinite. But in practical operational amplifier, the AV is not infinite. AV is some value 10 to the power 10, 10 to the power 20 like this. And in Zi input impedance omega ohm, giga ohm like this. So in ideal or practical case, there will be a difference. Some large value of voltage gain and input impedance in case of practical operational amplifier. But in case of ideal case, for analyzing the electronic circuits, normally we are analyzing in case of ideal operational amplifier. So to make our calculation is easy, the gain is infinite and input impedance is infinite. So what is all about is, suppose you are analyzing a particular electronic circuit, make the circuit, we will consider the ideal operational amplifier, then we will find out what are the output voltage, what are the input voltage, what is the gain, what is the input impedance, what is the output impedance. In ideal case, your calculation will be so much simpler. Then here, an non-inverting amplifier. So in non-inverting amplifier, it is one of the application of the operational amplifier. In non-inverting amplifier, this is your what? In case of operational amplifier, already this is your plus terminal, non-inverting input. This is your non-inverting input. Non-inverting input. And this is your inverting input. And this is your output. And this is your resistance R1 and this is your R2. So in non-inverting amplifier, so in previous slides, you see in non-inverting input, the gain is positive, means what? The input output voltage will be same. Phase difference will be same, means 0 degree. In non-inverting input, we are giving the input voltage to the non-inverting terminal, means plus terminals. So here, in case of simply, this is your plus terminal and this is your minus terminal. You are giving the input voltage at the plus terminal, let Vi, and here this is your resistance, and here like this. Okay. So this is your let R1 and this is your let R2 and let this is your V0. Okay. Simple circuit is like this here. Plus terminal, where this is your plus terminal, voltage is V plus. So here the mark as V plus. I am writing here that is your Vi. In negative inverting terminal, that is your what? This is your V0. Sorry, that is V0 and like this. So if in case of non-inverting terminals, so here this voltage is how much? you can say this voltage is how much? The difference voltage, this is your VD. The VD, this voltage minus this voltage. In virtual ground concept, if this is Vi and this voltage must be Vi. This voltage must be Vi. This voltage must be Vi. Since this is Vi, this voltage is Vi. Due to virtual ground concept, if this is Vi means this is Vi. To make difference voltage Vd equal to 0, Vd equal to 0. If this is Vi, this voltage is Vi, this is Vi. Okay, so you have to find out the voltage across R2. So that's why this is your V0, this is your R1 and this is your R2. So simply this is your what? This is your R1 and this is your R2, and here there is one V0. Suppose this is your here V0. We have to find out the voltage across R2. You have to find out the voltage across R2 here. This is nothing but that is your V2. Simply you can calculate current V0 by R1 plus R2, then find out the voltage, that is your V2 I to R2. So V0 is nothing but what? That is your I into R2. Current is nothing but what? V0 by R1 plus R2 into R2. This is all about your V0, and V0 by Vi, which implies V0 by Vi equal to R2 by R1 plus R2. Is that it? First look at this here. This is your Vi. Since it is an inverting non-inverting amplifier, we are applying the input voltage at the non-inverting terminal, that is your plus terminal, and here there is your inverting terminals. So since it is a non-inverting amplifier, op-amp as a non-inverter, due to virtual ground concept, that this voltage must be 0 because of what? The properties of the operational amplifier, gain is infinite, that is your V0 by Vd equal to infinite. V0 by Vd equal to infinite. If V0 by Vd is infinite, this voltage must be 0. If this voltage must be 0 here, that is your, this is 0, that is what? Suppose this is Vi, means what? This terminal is Vi. Your Vd equal to Vi minus Vi. Since it is Vi, this is Vi. Since this is Vi, this voltage is also Vi. This is short circuited, this is also Vi. So that's why this voltage you have to find out, because we are going to find out gain V0 by Vi. So here V minus, this is nothing but what? This terminal is nothing but V minus. So here, so V minus equal to what? V0 into R2 by R1 plus R2. Simply you can find out the voltage, find out the current equal to V0 by R1 plus R2, then find out this voltage, that is your I2 into R2, I into R2, I equal to V0 by R1 plus R2. I equal to V0 by R1 plus R2 into R2, then V0 equal to I into R2. That's why, so Vi, this is your Vi, this voltage is Vi. If this is this V minus, this is also V minus. V minus is how much? You can apply the voltage division rule. V minus equal to V0 into R2 by R1 plus R2 using voltage division rule. If this is V minus means what? This voltage is V minus. This is short circuit path. If this is V minus, this is V minus. This V minus is how much? Total voltage is your V0 using voltage division rule. V minus equal to V0 into R2 by R1 plus R2. So that's why. So V minus equal to like this, V0 into R2 by R1 plus R2. So V minus here, in place V minus, that is nothing but what? That is your Vi. V minus is nothing but what? That is your Vi. Because due to virtual ground concept, V plus, this voltage V plus means this voltage is also V plus. This voltage is also plus. So V minus equal to V plus equal to V0 into R2 by R1 plus R2. Then V0 by Vi equal to R2 by R1 plus R2. So here gain equal to AV. So AV equal to V0 by Vi equal to R2 by R1 plus R2. Sorry, V0 by Vi, just slightly modified here. Vi equal to, this is your V minus, this is your Vi, this is Vi. This is nothing but your what? V plus means what? This is V plus, this is also V plus. So V plus equal to like this, This is nothing but this is V plus means what? This is V plus due to virtual ground concept. This is V plus equal to or V here it is also VI. VI equal to V0 into R2 by R1 plus R2. VI equal to V0 into R1 plus R2. So V0 by VI. V0 by VI here V0 by VI yes. So V0 by VI equal to 1 by R2 R1 1 by R2 by R1 plus R2 which equal to R1 plus R2 divided by R2 which equal to R1 by R2 1 plus R1 by R2. Okay, this is your VI. Since this is your VI, this voltage V plus means what? This voltage V plus. This voltage V plus means what? This is also minus V minus equal to what? This is V plus. This V plus equal to V0 into R2 by R1 plus R2. V0 by R2 by R1 plus R2. So here or V0 by VI equal to 1 by this or R1 plus R2 by R2 equal to 1 plus R1 by R2. That is your gain or AV equal to 1 plus R1 by R2. In case of non-inverting operational amplifier, you will found the gain equal to 1 plus R1 by R2. So the voltage gain totally depend upon what? The value of R1 and the value of R2. This is two resistance R1 and R2. Suppose this is your 20 kilo ohm and this is your 10 kilo ohm. What? Your gain is how much? That is your what? 1 plus 20 by 10. 20 by 10 that is 2. That is your 2 plus 1 that is 3. The gain will be 3. So as far as design requirement, you have to change the value of the resistance. Then according to that, you will find the voltage gain. So this is all about your non-inverting operational amplifier. In case of non-inverting operational amplifier, you will found the gain is positive. The V0 by VI is a positive value. The positive value indicates that the input voltage and output voltage there will be the phase difference of is 0 degree. Here an example. Similarly, this is your R1 is your 24 kilo ohm, R2 is your 1 kilo ohm. Since it is a plus terminal here, so you are giving the input voltage to the plus terminal. That means what? This is a non-inverting operational amplifier. In case of a non-inverting operational amplifier, so V0 equal to what? V0 by VI equal to 1 plus R1 by R2. Here R1 is your 24 kilo ohm, R2 is your 1 kilo ohm, 24 by 1 that is your 24. So that is your what? 1 plus 24 by 1, 1 plus 24 equal to 25. So the gain, there is a ratio. So that is your gain, voltage gain equal to 25. Okay. So gain is 25. So in designing a non-inverting amplifier with a gain of 25, gain is 25. We have to design. Design means what? So only design means what? We are this is a question. So we have to design the non-inverting amplifier of gain is 25. Gain is 25 given. So that means what you will do? Gain is 25. This value is given, not resistance value. The gain is 25 is given. That means we are going to calculate the R1 and R2 value. How to calculate R1 and R2? As you know, the gain is 25. So our formula gain equal to G equal to what? R1 plus R2 by R2. That is your 1 plus gain equal to G. That is your V0 by VI. That is your 1 plus R1 by R2. So gain is 25. That 25 equal to the R1 plus R2 by R2. Or R1 plus R2 equal to R1 plus R2 equal to 25 R2. R1 plus R2 equal to 25 R2. That value is given. Or R1 equal to what? R1 equal to 25 R2 minus R2. The value is how much? 24 R2. So R1 R2 relation, that is your R1 equal to 24 R2. So our gain must be 25. So if that means what? Care should be taken. What is the value of R1 and what is the value of R2? The choice as far as the design requirement, what is the value of R1 and what is the value of R2? If R1 is your 24, R2 will be 1, because if R2 is 1, R1 is your 24. In that case only you will find the gain is 25. Are you getting or not? So if R2 is your 1 kilo ohm, then R1 equal to 24 kilo ohm. So here given the choice is what? If you choose R1 equal to R2 is your 1 kilo ohm, then R1 must be 24 kilo ohm. So thank you. We will do more and more number of varieties of the circuit related to operation amplifier. Thank you.